Okay, hello everybody again. So today I'm John, and today I'll present my work on word formation um, and efficient communication. And this work is done jointly with my supervisors Charles, Leah, and Yangzu. So let's first maybe go back several decades when there were only, say, landlines. And let's imagine that someone came up with the idea of a portable telephone. And wanting to share this idea with another person as a speaker, they'll need to somehow create a label for this novel idea. Although, right, there was no conventional way to refer to the intended message, many options nonetheless would have seemed plausible, right? Like they might, for example, reuse short forms such as phone or handy to signify certain aspects of a portable telephone. Or they might use compounds like cell phone or mobile phone to make it more distinct from existing concepts. And here we ask, what are some general principles that underlay novel words formed by speakers? So based on the communicative function of word formation, one general principle previous work proposed is that novel words should be informative about the intended meaning while avoiding redundancy. And in particular, for morphologically derived words and compounds, it has been suggested that the constituents should be sufficient but also necessary in signifying the intended meaning. And if we consider the previous scenario, this principle predicts that the speaker will more likely call the portable telephone mobile phone instead of brick or color phone, since in the first case, brick is not that informative, while the information and call is also redundant relative to phone. However, to our knowledge, there exists no work that investigates this general principle comprehensively. So the starting point of our investigation is a line of work suggesting that the lexicon is structured to support efficient communication. And this growing line of research shows that the lexicon trades off between two competing dimensions of informativeness, a measure of how faithfully intended meanings are conveyed from speaker to listener, and simplicity, a measure of the description lengths of the lexicon, like the number of categories in a semantic domain or average word lengths. So the theoretical framework in this line of research often invokes or can be related to information theory involving 6 main components. Right, so the first component is a set of meanings that people need to communicate and how probable the needs for communicating those meanings are. And naturally, 2 other components are real or tested speakers and listeners informed from data. So the speaker is just a mapping from intended meanings to some utterance, and the listener is a mapping from utterance to some reconstructed version of the intended meaning, like illustrated here, for example. So since the goal is to assess whether the attested speaker and listener efficiently trade off between informativeness and simplicity, there needs to be a way to measure these dimensions, or their opposites, communicative cost and complexity. So to make sure the attested mappings between form and meaning do not arise by chance, they are also compared to null hypotheses, null mappings. And such a comparison can be made in a plot like this, where a gray dot corresponds to a null mapping and color dots correspond to attested speaker and listener pairs. So in our work, we extend this previous line of research by asking whether novel words are shaped for efficient communication. And as an initial case study, here we focus on one of the most common word formation processes, compounding. So specifically, we hypothesized that the formation of novel compounds should near optimally trade off informativeness and word lengths, a particular kind of simplicity corresponding to the ace of uttering a word. We tested our hypotheses by adapting the previous framework to a scenario where a speaker expresses a single meaning, a single novel meaning while in a tested word form. For example, here the novel meaning historically is, say, mobile phone or cell phone, and the tested form for that is cell phone. And we compare this form to sets of plausible alternate labels of the meaning, sort of in the same kind of two-dimensional plot we have on the right. And in the following, I'll describe how we computationally formulated these components. Note, however, that throughout my slides, an italicized word, for example, the cell phone over here, represents corresponding word forms, and a word in quotes, like cell phone on the top right, represents a meaning, the meaning denoted by the word in quotes. So our entire computational formulation is based on two assumptions. The first one is we assume that a lexicon is a simple one-to-one mapping between forms and meaning, and that a lexicon for some language at time t+1 consists of entries from an earlier lexicon. So for example, this lexicon at time t on the left side, this table, consists of 4 word forms and 4 corresponding meanings. And a future lexicon, the one on the right, consists of an additional entry with a novel meaning, cell phone. So our second assumption is that each word meaning is represented by a word embedding, a vector trained on co-occurrence statistics from text. And these embeddings can be thought of as points existing in some space. And more closely related meanings are closer in that space. So cell phone is close to phone, but farther away from, say, cell. So now we can define the given these assumptions, now we can define the components of our framework. So the first component is the meanings the speaker wishes to express. So since we're interested in novel compounds, we set this set of novel meanings that exist in the future. We set this set of meanings to a single novel meaning that exists in a future lexicon at time t+1, but not in lexicon at time t. So in the example here, it would, same example from before, that would be the meaning cell phone. The second component is how the attested speaker maps meanings to word forms. So this is also straightforward since we're only working with meanings that are really lexicalized in a future lexicon. So our speakers just always map a novel meaning to its attested form in history. So we define the listener then for interpreting word forms uttered by the speaker in 2 ways. So in one case, if the form is in a lexicon of the listener, which we define to be the lexicon at time t, then the listener simply maps the form to its corresponding meaning in their lexicon. Otherwise, when the form is a compound, like in this case here, the listener first obtains the meanings of the constituents from their lexicon, and then they infer the meaning of this novel compound form by taking the average of the constituent meanings. So given these speakers and listeners, we still need to assess whether they near optimally trade off between informativeness and word length. So for simplicity, communicative cost, we define it as the cosine distance between the speaker's intended meaning and the listener's reconstructed meaning, inferred from the reconstructed meaning that's inferred from the speaker's utterance. And for word length, we also simply define it as the number of letters in the word. So for example, in this case, at the length, this example here, the word length would be 9. So the final component required to test our hypothesis is the alternate speakers that can be compared to the attested word form with respect to the speaker's intended meaning. So for all alternatives, we use the same listener as the one defined in the previous slide, but we alter the word form deterministically produced by the speaker. And this set of alternate forms is equal to a few things. First, it could be all the existing words in the lexicon at time t. And it could also be all possible compounds where the head word is the nearest semantic neighbor of the attested head word. or compounds where the head word is closely related to the intended meaning. So using the methods I'd explained, we assess the efficiency of 230 English compounds that emerged in the past century. So here I'm showing the plot that compares the attested form cell phone, shown in blue, to alternate forms shown in gray. The black line shows the optimal frontier, that is, forms with the lowest length and communicative cost for expressing the intended meaning that's shown in the header. We observe that long optimal forms tend to be more semantically transparent and vice versa. For example, if you compare wireless phone to phone. So relative to this frontier, the closer the forms in blue or gray are, the more near optimal they are. Thus, qualitatively, we can see that the attested form cell phone is relatively efficient and much more near optimal than most alternate forms in gray. So here are similar plots, but for other intended meanings. And within this sample, we can get a sense of attested compounds like chairperson that are very close to the frontier, and others that are relatively far, like highlighter. So we summarized these comparisons in the previous slide we made for 230 compounds, attested compounds, by ranking roughly how many word forms are strictly better than them in the large set of gray dots that we have generated. So here the histogram on the top left compares the ranks of attested compounds to the ranks of a random sample of the large set of alternate forms we constructed, and a subset of attested forms are annotated. So the one on the bottom left compares attested compounds to a more restricted subset of alternate forms. And we see that for attested compounds that are in blue, their ranks tend to have a strong skew to the right, so it tends to attain much higher ranks compared to alternate forms. As an additional analysis, we tested whether both dimensions, word length and informativeness, contribute to the tendency for forms, attested forms to be near optimal by controlling for communicative cost and length. So on the top right, we controlled for word length, and on the bottom right, we controlled for communicative cost. And we see the same trend as before when comparing both dimensions. So taken together, these results suggest that attested compounds near optimally trade off between informativeness and effort measured by word lengths. Okay, so to recap, we extended previous work on efficient communication to investigating word formation, and we provided some evidence that novel compounds support efficient communication. And currently, we are extending this work by trying an average case analysis instead of working with one intended meaning at a time. And we hope to extend it to different languages and word formation strategies beyond English compounds. Okay, cool. So thank you for listening to my presentation, and I'm happy to take questions.